Hello and welcome to this session. Today we're going to talk about how to build robotics applications faster with simulation. My name is P.D. Datta. I'm a Senior Product Manager in AWS RoboMaker. Here's what the next 30 minutes is going to look like. I'm going to start with an introduction to AWS RoboMaker. Then we're going to talk about a few use cases with testing and simulation with AWS RoboMaker. Then we're going to build a CI/CD pipeline with some of the AWS services. And then we're going to close out this session with a demo. So let's start with what's a robot. When we say a robot, we typically have different ideas that pop up in our heads. Some of you might be thinking of a humanoid robot. Some of you might be thinking of a consumer robot like a vacuum cleaner, like the Roomba. For us, a robot is any autonomous machine that is capable of sensing its environment, can perform computations, make decisions, and ultimately take an action in the real world. There are many industries where robots play an important role. It spans from logistics to construction to retail to consumer home products. Each of these robots are demanding more and more autonomy and more intelligence from the robots that operate in them. For example, if you have a robot in the warehouse, you would expect it to navigate and detect objects as it moves around the warehouse floor so that it can safely pick orders and move packages. To give you a general idea, robotics follows the same process you might recognize from the traditional and well-established software development processes. You select a software framework, you develop the application, you test the application, and then you deploy that application onto the robot. What's different in robotics is not all developers have access to the physical hardware. And there are three primary reasons for it. One, it can be extremely costly to dedicate hardware to every developer. Two, typically what's being used in prototypes are not the same thing that gets deployed in commercial or production. And three, since it's not possible to do all the tests in the real world, this is where simulation comes in. You can use simulation for testing and fine-tuning robotics applications before you deploy it to the physical hardware. Robot Operating System, or ROS, is the most widely used software framework for robotics. And that is the reason why we chose ROS. ROS is actually not an OS. It's actually a middleware. It's a collection of tools, conventions, and libraries. It just behaves like an OS because it gives you low-level device controls, package management, and message passing. ROS handles message passing in a publish-subscribe architecture, where you have nodes and you have topics. For example, you can have a health check node that publishes the CPU percentage, the battery health information to a diagnostics topic. And you can have a metrics node that listens to that topic and subscribes to it and collects the information. Gazebo is an open source physics-based simulator that is built for ROS, and RoboMaker supports the Gazebo 7 and Gazebo 9 versions. We launched AWS RoboMaker at reInvent 2018. It is a service that makes it easy for developers to build, test, and deploy robotics applications at scale. Think of RoboMaker as three independent yet integrated capabilities. First, the cloud extensions in AWS RoboMaker offloads the more resource-intensive compute processes required for robotics applications to the cloud, and then it frees up your local compute resources. RoboMaker provides these cloud extensions as open source ROS packages so that you can build your functions on the robot by taking advantage of the cloud APIs, all in a familiar software framework. These extensions make it easy to integrate with AWS services such as Amazon Kinesis video streams for video streaming and Amazon CloudWatch for logging and monitoring. Second, AWS RoboMaker provides a fully managed robotics simulation service that automatically scales the underlying infrastructure based on the complexity of the simulation. In RoboMaker, we have the concept of a robot application, a simulation application, and a simulation job. A robot application is what you would typically deploy onto the robot. Simulation applications are used to model the simulation aspects of the physical world. Now, using the RoboMaker simulation job, robot applications can run inside simulation applications, and you can collect and visualize the data. So once you've developed the application, you can deploy this robot application onto the robot using RoboMaker's fleet management over the air, all with a few clicks in the console. Now, if you go to the RoboMaker console, you can easily get started with some of our sample programs, or we call it sample applications. It's just an easy way to check out how RoboMaker works. So let's shift our focus and look at some benefits of testing in simulation for robotics development. Now, we've heard from a number of customers that simulation is important for use cases such as regression testing and testing multi-robot interactions. For example, say you're an online retailer with warehouses across the country. These warehouses have robots running in them, picking up packages from point A and delivering them to point B. You also have humans working in these warehouses. Testing this human-robot interaction is super important, and this is where simulation can actually be very beneficial, because you can test these scenarios safely. The top 3 reasons why customers use simulation are, 1, simulation gives you the ability to reproduce and test the exact scenarios that have triggered unexpected behaviors in the past, including edge cases and unsafe conditions. So let's continue with the example of the imaginary warehouse. You have sunlight coming in from one of these skylights, and it's reflecting off of the cement floors. And this makes the perception stack on the robot behave in an unexpected way. Now, it might seem like an edge case, but these things happen all the time. This is difficult to reproduce when testing with physical robots. But with simulation, you can repeatedly run these scenarios and create a test case around it so that the robot doesn't behave unexpectedly when it encounters this situation in the future. Second, you can speed up the clock and run simulations faster than real time. So you're producing results in a fraction of the time than it would take on a physical robot. Third, you can expand the test coverage by programmatically testing many scenarios using parameterized and repeatable simulation. So this would ensure that when you take a robot and put it in a new warehouse, it can immediately get to work. So overall, simulation helps you increase your development and testing velocity, and it helps you improve your code quality as well. Now, RoboMaker brings the cloud scale to simulation. There are 5 reasons why customers use RoboMaker. First, it provides a fully managed solution, which enables you to run simulations consistently and reliably. With a simple API call, you can test your robotics applications in the cloud and at scale. Second, RoboMaker provides the ability to run hundreds of concurrent simulations with the RoboMaker Batch API. Third, with the pay-as-you-go pricing, you only pay for the simulation resources that you've used. It's measured in a minute's granularity. Fourth, you get the benefits of managed service with ROS and Gazebo built in, which will actually free up your engineering resources. You can also visualize and interact with the robot using the open source visualization tools such as Gazebo, Arvis, and RQT in simulation. Finally, the ease of integration with the breadth of AWS services enables you to connect your ROS application and tooling with services such as Amazon CloudWatch and AWS Code Pipeline. To look at some of the customer use cases and examples, iRobot uses RoboMaker for automated simulation-based regression testing in a CI/CD pipeline. So they're running more than 40 automated tests for each code commit and more than 500 automated tests for each release candidate. So they were able to increase their release velocity and improve their test coverage by using RoboMaker. Bastion Solutions is another customer that runs simulation that support a fleet of robots to test multi-robot navigation, orchestration, and interaction in Gazebo. The Takinaka Corporation creates gazebo worlds using building information modeling or BIM files that they can deploy directly to the robots. So let's look at how you can build a CI/CD pipeline and test in simulation with AWS services. So today we're going to run tests for one of the sample application programs we have in RoboMaker. This is a CloudWatch sample application where a turtle bot is placed in our simulation bookstore world. So in this test, we specify a random point as the destination, and the robot uses its navigation stack to find the optimal route to navigate to its destination. On the left-hand side, what you see is the robot's view of the world that it has mapped with its onboard LiDAR. There's a small square box on the right of that picture. That's the robot. And the squiggly line is the path that it is plotting. On the right-hand side, you see a 3D view of the bookstore world in the gazebo simulator. So today we're going to do a single test of whether the robot can successfully plot its path and complete its navigation. Then we're going to parameterize it to check if it can complete one successful navigation or n successful navigations. So one of the AWS services we will use today is the AWS code pipeline to trigger and orchestrate the process. It's going to get kicked off when we push our code to GitHub, and then it's going to orchestrate each of these processes. Another AWS service that we're going to use is AWS Code Build. It's going to take our software to build it, to bundle it up. It's going to upload it to S3, and then it's going to trigger the test running in simulation. I've also used a Lambda function to trigger these tests to run in RoboMaker simulation. This is not a necessity. You can use the AWS CLI or the SDK. I've used the Lambda function just for the convenience because it's just an easy way to write our tests and then trigger the simulation jobs in RoboMaker. So quick note about the tests. We're going to dedicate one test per simulation job. Again, this is also not a requirement. You can have multiple tests per simulation job. It'll really depend on your use case. So we work with the ROS ecosystem. So our test is going to be a simple ROS node that monitors the metrics topic to calculate the distance to goal metric. And then it will publish to a couple of ROS services to cancel the job and tag the job. These ROS services are built into RoboMaker simulation that you can use as convenient functions. So once the tests have passed or failed, it will auto-cancel the simulation job when they reach the terminating stage. And it will also be tagging the simulation job with output and the final result of the test. Now, a lot of our customers have their own test reporting system that they will probably hook into their CI/CD pipeline. Today, we're just going to keep it simple. We're going to use AWS resource tags on the simulation job itself. So if I had to draw up an architecture of what I just talked about, it's going to look like this. So this is the CI, or the continuous integration portion of the architecture. So in step one, I'm going to build the code locally. I'm going to test the code locally, and then I'm going to merge it to the integration branch. As I merge it to the integration branch, AWS Code Pipeline is going to kick off a pipeline starting with AWS Code Build to build and bundle the resources. Once these source files are copied into S3, it's going to invoke the AWS Lambda function that will trigger tests in RoboMaker simulation. The continuous delivery portion of this architecture is very similar to the CI portion. It's just you are actually checking in your code to something like a release candidate. So it's more rigorous. The tests are more rigorous. So if I have to wire both of these together, it's going to look like this. The CI portion, if the tests pass in the CI portion, then it will try to merge the code into the master branch, and then it's going to kick off another pipeline. If the tests pass there, then your code is ready to be deployed to your robots, which you can do over the air by using RoboMaker's fleet management capability. Okay, so let's see if we can replicate that with a demo. Now in this demo, I've fast forwarded some of the steps such as build times and simulation job start times. So the duration of the demo is not the accurate representation of how long it would take you, but it does show the different pieces you need to create a CI/CD pipeline and test your application in simulation. So I'm going to start in our Cloud9 developer environment. I've already checked out the CloudWatch sample application code from GitHub. I've made a small change to our README file. This is what we're going to use to confirm everything is working well towards the end. So I have a simple build spec file here, which we're going to use to configure code build. It's going to install the required dependencies and some of the code we need to run. It's going to execute the build for us. And then in a post-build step, it's going to bundle up our resources, put them in S3, and invoke the Lambda function to kick off our tests and simulation. So we'll take a look at the Lambda function a little later. Before we start creating the CI/CD pipeline, let's take a closer look at the test itself. So in this test node, we have, this is the test node that we've added to the CloudWatch sample application. It's going to be monitoring our metrics topic. It's going to look for the number of successful navigations. And we're going to configure that by setting an environment variable for it. So the navigation success count, that's the environment variable we're going to use. And as it monitors the distance to goal metric, it's going to call those onboard set tag service, and eventually it's going to cancel the simulation job programmatically. Okay, so let's go ahead and create some AWS resources. First, we're going to go to the code pipeline console and create a pipeline. We're going to give it a name. I'm going to choose one of the existing IAM service roles because I already have created it, but you can do it in line. We can select the source from a number of options, but we're going to choose GitHub today because that's where our sample application code lives. Provide a repository that I've already forked the sample application to. And then we're going to grab the feature branch where I'm going to run the tests on. Now I'm going to choose GitHub's in order to automatically kick the pipeline off when I push the code. The next step is the build stage. I'm going to choose AWS Code Build for the purpose of this demo. You can also choose Jenkins. First, you have to create a project inline. So when I create a project, I'm going to start by giving it a name and a description. And then I'm going to choose the OSRF Docker image. It's a Linux image for ROS Kinetic. This image has all the dependencies that I need for the demo. I'm going to run it in privileged mode. I'm going to choose an existing service role because I already have these AWS resources created for myself. And then by convention, I'm going to use the build spec file that I showed earlier in the demo. Okay, so it looks like the build step has been successfully created, which is great. So I'm going to go next. So the next step talks about deploying this application. I'm going to skip this for the purpose of this demo because the fun stuff is actually happening in the build stage. So I go back to the code pipeline console, review it, and click on Create Pipeline. So pipeline's been created. It will automatically kick off a build for us in the background. Once we copy over the source to S3, the build is actually going to execute in code build. So while the build is executing, we can dive into the build and see what's happening under the covers. So we have one build underway, which is good. We can see a little more information about the build. Probably the most interesting thing that we can do here is pop up and tail the logs. Here we can see that it's installing some of the dependencies. So it looks like everything is progressing well. So while the build continues, let's take a look at the Lambda function. This is the last step of the build, to invoke the Lambda function so that it can kick off the tests in RoboMaker simulation. So here we have a simple scenario spec where we name a set of tests that we want to run. We are configuring them by setting environment variables. There are a number of environment variables here in the sample application, but the most important one is the navigation success count. We will do one simple test to make sure that it does one successful navigation. Then we'll do a longer running test to see if it can do 3 successful navigations. So the rest of the function is a basic simulation job request in RoboMaker. It has the robot application, the simulation application, information about failure behavior and the role, and some networking stuff that you need for this demo. So if I click test here, we can take the document and we see 2 running simulations in RoboMaker. So we can jump into one of them and see the tag section and see that it started tagging automatically. So I'm going to pop up a couple of the GUI tools to see what's actually happening. So inside the terminal, we can monitor the metrics topic, that it is calculating the distance to goal metric. As the robot gets closer to the goal, the value will count down to 0. So I'm also going to pop up RViz here so that we can see the robot's view of the world and the path that it is plotting. So if I've done my job right, I should be able to zoom out and see the robot. Yep, so it's right there at the bottom. I can see the robot here getting closer to its goal. It successfully completes its navigation. You can see the distance to goal metric get close to 0 right about now. So the robot has plotted its next route and it's navigating to its goal. In the background, you can see that the tags have started to show up, reporting successful navigation status. So it looks like everything is going well. So I'm going to jump ahead in time a little bit. We have configured this for 4 successful navigations. So we should see the last navigation pop up here. And we should also see the overall test result in the background. Yep, so we can see that the test has passed. Simulation should start shutting itself down. So you can see that it has started terminating. So in the list view, one of them is canceled, one of them is terminating. Everything looks good so far. I jumped to the build stage. Looks like the builds are running. So I jumped ahead and went to the end of the build. So we can see that the build has succeeded. I'm going to go back to my pipeline and see the state. And looks like the first pass is successful, which is great. So the source step has completed, the build step has completed. We can check the status of the simulation job one more time. So if we go inside one of them, we can see that that both of them has passed, which is great. So the tests have passed. So I'm going to jump back to the development environment. And then I'm going to make a commit to GitHub. So once we push this to GitHub, we can see our pipeline automatically get kicked off again. Before doing the commit, I'm going to add a simple commit message. This is what we're going to use to confirm that everything is working well. So I will push this back out to GitHub. And if I go back to our pipeline, we can see that the source step has kicked off. Once this gets copied over to S3, we can see that the build step will also start to execute against our latest commit. And there it is at the bottom. So we can see that the latest commit has completed, and you can see the updated message that we updated in the code. So just to recap, today we talked about the benefits of simulation in robotics development. We discussed some of the customer use cases, such as running regression testing and multi-robot simulation. We talked about why customers use AWS RoboMaker to run tests in simulation. And then finally, we actually saw a demo of how you can build a CI/CD pipeline with AWS services to accelerate your testing and increase test coverage. I hope you enjoyed this session, and I thank you for your time.